The challenge for the fertilizer industry is the fact that we have a very carbon-intensive technology which is vital for growing food. But also we know that world leaders have now accepted the fact that we are behind the eight ball and we need to catch up fast. Fertilizer production globally is broadly the same. Really, they are using processes that are about 70 years old. Non-organic fertilizer has a huge carbon footprint.
We need to reduce the emissions coming from the energy and industrial sectors if we are to reach net zero. CCM's technology captures carbon dioxide and other waste streams and either stores the captured material or converts it into resources like fertilizer or plastics.
I'm going to borrow the quote from Mahatma Gandhi: waste is only a resource in the wrong place. That is the core tenet to what we do. I'm Pavel Kishlevsky, Chief Executive of CCM Technologies. Well, we have a fairly strange origin in the fact that Professor Peter Hammond and I were parents at the same school. My background is finance, his is a chemical engineer, and it was the combination of those two skill sets that founded the company back in 2011. When Peter and I founded the company, his intellectual property, which he's been developing over 25 years, is around CO2. But interestingly, he was looking at it as a solution for some of the engineering challenges that he was solving for big companies. And he turned his mind to suddenly realize that actually there was a way of capturing the CO2, the devil incarnate, and actually using that for a profitable and sensible method.
It's got to be better, it's got to be as easy to use, and it's got to be cheaper. And we've appreciated that from the beginning. There was a sort of circularity developing in the whole process, and that led on very rapidly to us appreciating that if we could take materials from their end of life within waste and actually reintroduce them to the beginning of the cycle, that would be a really good process. Conventional nitrogen fertilizer production in particular is very energy intensive.
In some cases, 4, 5, 6, 7 tons of emissions of CO2 for 1 ton of fertilizer.
Whereas our materials are neutral in that sense.
CCM is able to produce fertilizers with a zero carbon footprint, or even potentially climate positive, i.e. it's removing carbon from the atmosphere. The equipment you can see behind us is relatively straightforward. It's a mixing and blending technology, but is around really 3 inputs.
Those are fibrous materials, any sustainable source really.
So grass, straw, wood chip, or digestate cake.
Ammonia, which is recovered either from food or animal waste streams. Then carbon dioxide, which is generally recovered in our case from exhaust streams.
And it's those 3 components which are currently considered waste that we can turn into something that's both valuable and also good for the environment. Wastewater is a very good example. At the moment, they are discharging phosphorus and ammonia into the groundwater. So rather than have them as a waste, recycle them back in and use them as the core nutrients to build fertilizer with zero carbon footprint. The key part of CCM's process is to deliver the farmer a fertilizer he actually wants and needs. So it's customizable to its nutrient ingredients. We have a solution that can be put to the rice crops, the largest crop in the world, but also sub-Saharan Africa as well, where clearly soil temperature is a big issue. We're also putting both organic matter and carbon in the form of calcium carbonate into the soil. So we're putting it back where it started from and closing the cycle. Another of Peter's real tenets is to ensure that the price point of the product is at least the same as the current environment, if not slightly better.
Then you can actually mobilize agriculture as a massive tool in fixing the environment.
We have to create a better climate and a better world for my grandchildren and everybody else's grandchildren.
Agriculture is using a range of finite resources which will run out. Our process will allow the extension of those finite resources, but also in recovering them from waste materials, it actually creates a new resource base, but without changing the fundamental ways in which you deliver agricultural production.